how could a rogue planet have liquid water on its surface? Would aliens be communicating in something other than radio waves? And will dark energy overcome the gravity of supermassive black holes in the Big Rip? All this and more in this week's question show. It's time for the question show. Your questions, my answers. Now, as always, wherever you are across my channel, if a question pops into your brain, just write it down. I will gather them up and I will answer them here. Benoit Heinz 5357. I don't understand how a rogue planet far from any star could have liquid water on its surface. Why does this thick hydrogen atmosphere not freeze and snow down to the planet? So this question is related to K2-18b, which is the new Hycean world candidate that astronomers announced, seen with James Webb in the last week. And this idea is Hycean. This is a portmanteau of hydrogen and ocean, although it should be Hycean world. So maybe that's the right way to pronounce it. Someone in the comments suggested that, and that might be right, but it sounds wrong. I don't know. Anyway, these are worlds that have a very thick hydrogen atmosphere that is surrounding the planet, and they have a lot of water. And it's these sort of two things working together that astronomers are looking for. And what makes the Hycean worlds very exciting is that hydrogen is a greenhouse gas, a very, very powerful greenhouse gas. And so you're going to get a habitable zone on a planet that is much farther away from the star than we would expect for a terrestrial world, something like Earth with oceans and atmospheres and things like that. That, you know, a typical, like, you're going to get all the water boiling on a Hycean world all the way out to about 1.6 astronomical units, but really it would remain habitable all the way out to about 3.5 astronomical units. That's the distance from the Earth to the sun. And so you've got this much wider area, and planets that were in the outside of the habitable zone. Now you're like, wait a minute, maybe we need to investigate these planets as well, because if the conditions are right, you could have a habitable planet. So the question that you're asking is related to the idea of a rogue planet. I brought this up briefly in the Space Bites episode that we talked about this. And that comment comes from the interview that I did here on this channel with Dr. Niku Madhusan, who was one of the discoverers, one of the, I guess, theorists behind this idea of a Hycean world. And so we talk about the Hycean world and go into the potential of them being liquid water even as a rogue planet. And so there's like a couple of ways this could happen. One is that the Hycean world is the exomoon of a brown dwarf or some large, like, mega Jupiter planet. And as we know here in the solar system, when you get worlds that are orbiting around Jupiter, Saturn, you get these tidal forces that allow them to, it will melt their mantle. You get Io, right? You get the most volcanic place in the solar system is far away from the sun, but then you can get a liquid ocean underneath the shell on Europa. And so when you add those things together, when you get this world that holds in its warmth very well with the tidal interactions of a larger planet, then you could have a lot more options for where you could have liquid water on the surface of this world. And then the other possibility is that it could have a lot of radioactive material inside, in the core and in the mantle of this planet. And again, because the planet has this thick hydrogen atmosphere, it acts like a blanket that keeps the warmth in, that it could be habitable even in places where it's not getting any regular illumination for long periods of time. So much longer than if we took Earth and just stuck it out in deep space, it would freeze. It would still remain warm down at the bottoms of the frozen ocean because of this radioactive heat inside the Earth. And you would expect something, but maybe it would go all the way up the water column and still keep the whole planet's ocean liquid. Now, this is all still super theoretical. We have only discovered a couple of rogue planets. We don't know if this really is a Hycean world or if it just has some of the right signatures, that if these things are even real. But this is how science works, and it's pretty exciting that they theorized a new type of planet, looked in a different area for a different kind of characteristic, and one of these worlds might have turned up. Now, you might have noticed the planet name that has appeared over my shoulder, and this is a way for you to vote, for you to tell us which of the questions you thought was the best this week. So we're going to have a different planet for each one of the questions, and then you can just write down in the comments down below which you thought was the best question, best answer, best combo, the thing that made you think, whatever, and we will count up all of those as votes, and then next week we will celebrate the one that the most people voted for. Stephen King 7352. I wondered, how do gravitational wave detectors sort out any gravitational background noise from the big events, like with early radio telescopes and cosmic background radiation? Is that even an issue? The LIGO observatories are designed to pick up colliding black holes, colliding neutron stars, and they're not able to pick up frequencies that are longer than the sort of very short chirp that you get from one black hole with 20 times the mass of the sun crashing into another black hole with 20 times the mass of the sun. That's a very short frequency. You don't get the longer events. It doesn't have the sensitivity to pick up this gravitational background radiation, the one that was found with the pulsar timing array. It can only find these short-term chirps. It can't see supermassive black holes merging, and it can't see stuff that's small. It can't see a star with a wobble. It probably can't see two white dwarfs crashing into each other, but maybe. And so there's a lot of other gravitational wave events. Like, it can't detect me waving at you, even though I am releasing gravitational waves as I wave. So there's a very specific range that it's able to see. And you're like, why doesn't it pick up all kinds of other stuff? And the reason is because the two observatories that make up LIGO, there's one in Eastern Washington and there's one in Louisiana, and they are separate by thousands of kilometers, so that all of the regular random events that happen, earthquakes, trucks driving by, people walking around, people dropping books, like all of those will be picked up by one of the detectors. But the key is that you have to get it picked up by both detectors with the right delay according to the speed of light. As you imagine, if I drive the truck really close to one of the LIGO detectors, it's going to pick it up, but the other one's not going to get it. But if a black hole collision goes off, the gravitational wave is going to move past one detector, it's going to be detected, and then milliseconds later, it's going to pass the other gravitational wave detector right on time, same signal, and that's what gives the scientists a certain level of certainty that they actually did detect a gravitational wave from a black hole collision. But there are all kinds of anomalies, all kinds of things, and so they run machine learning algorithms to look at the different kinds of wibbles and wobbles and jitters that the detectors would experience so that they can throw out anything that is not relevant. And you're left with the black hole collisions. Terrence Abel 5024. Has anyone thought about alternate communication other than radio? So this is, of course, SETI looking for signals coming from extraterrestrial intelligence, and the long arc of SETI history has been in the radio waves. People set up these giant radio telescopes. They look into space for a signal from an alien civilization. And radio is great because it propagates well. You can use a very, very large radio dish to receive a signal. You can do radio astronomy during the day. When the sun is out, you can still point at the star and receive a signal. But also, the universe is busy in a lot of other wavelengths, in visible light, in infrared light, in ultraviolet, in X-rays. But certain wavelengths of the radio spectrum just are not used at all by nature. And so what's great about SETI in the radio perspective is that if you see certain kinds of signals coming at certain wavelengths, then it has to be coming from an intelligent civilization. If you even just detect it, then you have to assume that someone built a machine and then sent that message towards you. But of course, that is not the only signal that astronomers are looking for. They've considered every possibility. There's a recent paper that I'm really trying to get my hands on where they identified, I think, like 70 different technosignatures, so ways that advanced civilizations might be broadcasting their existence, either intentionally or unintentionally. They're having a nuclear war, or they're using greenhouse gases in their atmosphere. And so when you look at other kinds of radiation, like we have the electromagnetic spectrum. You've got radio waves are one type of electromagnetic spectrum, but you also have infrared, optical, ultraviolet, like these are all just photons. And so whether you have a telescope or whether you have a radio telescope or whether you have an X-ray telescope, you're just looking for photons coming from some location. And so if you want to do something different, like some kind of multi-messenger astronomy to search for aliens, then you've got two other possibilities that we know of. You've got neutrinos, which are hurled out from supernova explosions. They come from the sun, and they would be great. Like you could detonate a nuclear weapon in a certain way in space, and that would send out a pulse of neutrinos in all directions. Maybe there's a way to channel it so you could send them. The problem is that neutrinos are really hard to capture and detect. And so like, what would a neutrino telescope designed to search for aliens look like? We don't know. And then the other possibility is gravitational waves. But again, like the only way that you can detect gravitational waves is when you've got incredibly massive objects crashing into each other. Black holes, neutron stars. And so like, yeah, you could imagine some alien civilization where they are crashing black holes into each other in Morse code, and then we could detect them with our gravitational wave observatories, or we learn a way to make much better gravitational wave observatories, which would be cool. And then you could like jiggle mass around, and you could detect the jiggling mass from far away, which would be really cool. We get this comment all the time. People say like, what makes you think aliens are going to communicate in radio waves? They probably don't. Right? Like, sure, they've come up with something better, something new, some other way to communicate. But we would hope that they would remain backwards compatible, that they would think, well, we went through a phase where we learned how to use radio waves. So it's possible that other civilizations are still in the radio wave phase. So let's do them a favor and communicate in a way that they can detect us. Like, how can we search in ways that we haven't thought of yet? All we can do is use the tools at our disposal. You know, if you've lost your keys, and you've like checked your pockets and you've checked your cabinet, and then Einstein calls and says, have you checked in the fourth dimension? And you're like, how? He's like, that's not my problem. Figure it out. Speaking like Sabina Hassenfelder's Einstein phone. So yes, SETI researchers have absolutely thought about every single creative idea they could possibly think of so far to search for evidence of aliens beyond Earth. And so far, none of those ways have panned out, and people think of new ones. It doesn't hurt to come up with new ones and try them all. T-Home. In the recent paper, Earth as a transiting exoplanet, physicists say that James Webb has detected signs of intelligent life on Earth. Does that mean that JWST is giving wrong results? So that paper, Earth as a transiting exoplanet, I hope you found that story on Universe Today, because I feel like we were one of the only people that actually report on that. But yeah, so what happened was researchers looked at the kinds of observations that JWST is capable of making, and then they compared that against the kinds of signatures that Earth is giving off. So in the wavelengths that matter to JWST, it is the kinds of gases in the atmosphere of Earth. Things like oxygen, methane, carbon dioxide, and then especially chlorofluorocarbons. These are the chemicals that we used for cooling that made their way up into the atmosphere. They're the ones that helped make the ozone layer whole over Antarctica. So based on this paper, if Earth was at a certain distance away from us, within some range, and you were able to point Webb at Earth, then it would be able to detect with enough certainty the kinds of chemicals that you could then assign as to a technological civilization. And so you're asking, like, does this mean that the telescope is giving wrong results? No, not at all. It's just that they haven't pointed it at another potential Earth yet. When I think about all of the exoplanets that we've reported on for Webb so far, like maybe there's been 10, like a hot Jupiter, 2 of the planets in the TRAPPIST system, some of the WASP planets, this K218b. So there haven't been a lot of planets so far. And the problem is that we don't even know of any Earth-sized worlds orbiting sun-like stars in the habitable zone so far. With the Kepler survey, with the TESS survey, none of these have been found. Now, theoretically, TESS will find 1 or 2 Earth-sized worlds around sun-like stars in the habitable zone throughout its time in orbit, hopefully. And if not TESS, then there will be a lot of other telescopes coming along that will be able to do this work. There's Plato, there's Ariel, there's the ground-based telescopes like the extremely large telescope. So hopefully one of them will turn up the presence of this planet. And if that planet is within a certain amount of light years of us and it's separated far enough from its star that the coronagraph onboard James Webb would be able to do this work, then it should be able to analyze the atmosphere. And if it does, and if that planet has chlorofluorocarbons in the atmosphere, then James Webb would be able to detect them as well as other chemicals that then astronomers could make some kind of prediction that there is probably life there. But it would be the very limits of what Webb can do. We're going to need a bigger, better telescope to do that. There's a couple, right? There's the Habitable Worlds Observatory. This is the follow-on telescope to Hubble that is going to come out in the 2030s, 2040s. There's going to be the Extremely Large Telescope, which can do some of this work. And then, of course, there's Ariel, which is the telescope coming from the European Space Agency in 2028. And that one will be analyzing the atmospheres of thousands of exoplanets. And so hopefully it can make the discovery. But first we need the targets, and we don't even have any targets yet. Tim pointing. Any idea what Betelgeuse is doing right now? It had been getting brighter, then dimmer, then I can't find anywhere online where there's an up-to-date brightness curve for it. I don't know what it's doing today, but there are astronomers watching the star very carefully and recording its brightness every single day. I'm just not sure if they report it online anywhere. If anyone knows where they do that, I'm going to check the American Society for Variable Star Observing, and I didn't see any listings, but we know that Betelgeuse dimmed suddenly, and it was probably due to dust, and fairly recently it actually got even brighter than it normally does. And again, it is a naturally variable star. I mean, think about Betelgeuse. We think about this like red star in the sky, but in fact, it's this giant monster star that goes much bigger than, like, it's out beyond the orbit of Mars in our solar system. You imagine the star that's that big, but it also expands and contracts a bit, and it changes in its brightness as various sunspots. It has sunspots on the surface of the star that are like a third the size of the star. So imagine sunspots that are hundreds of millions of kilometers across. Like, it's a crazy, crazy star. I would love to be able to see that up close. And so there are these natural variations that astronomers have been tracking for well over 100 years. And what was surprising was the recent dimming, because it was more than anyone had ever seen. And it turned out that that was, due to some dust cloud that was probably in the way, and it had cleared out, and then it went back to normal, like when a cloud goes in front of the sun and it dims down for a while. One of the kind of intriguing clues or thoughts is that based on the variations that it's going through, it's in one of the final stages of its life. And so that could mean that it's going to explode as a supernova sometime in the next 500 to 100,000 years. Like, we still don't know the number, which would be crazy if it did that. I mean, it would be amazing to see it in our lifetimes. It would be the brightest star in the sky. It wouldn't be as bright as the moon, but it would still be incredibly bright, much brighter than Venus. You could read by it at night. You would see it during the day, and we would get like an unprecedented understanding of how supernova worked, because this is one of the most studied stars in the universe. And to know exactly what happened to it before it exploded, and then to watch it go through this process, and then to see the remnant left behind, like a giant black hole interacting with this cloud of gas and dust, or like some kind of neutron star or something, plus the flash of neutrinos that we would get. In fact, it's so close that we would get the alert of the neutrinos before the explosion went off. And so we would know, oh, Betelgeuse went off, let's go take a look. And then a few minutes later, you would actually see the star explode. So I don't know sort of what its current state is. And if someone knows where this is tracked online, please let me know. If you want to support the work we do at Universe Today, consider joining our Patreon club. Your support lets us have a minimum of ads and no sponsorship messages. Patrons get no ad for life on universetoday.com. Want the extra parts of the live stream that aren't in this edited version? You can sign up for a special Patreon-only podcast feed and get the overtime segments, as well as other special behind-the-scenes episodes, including our monthly patron-only question show. Thanks to everyone who's already subscribed, and welcome to the recent newcomers: Richard Dietz, James Mueller, Jan Osowski, Tracy Spinka, Lavi, John Mandrick, Pertu Lucanson, Janet Goldsboro-Jones, Barry Eccles, Ivan. Join the club at patreon.com/universe today. Now, I know you like to watch the video version of this episode, and I don't have a problem with that. Like, obviously, Chad puts in a lot of work to make the pretty videos and animations and stuff that go along with the answer. But if you want to sort of see on top of everything while you're walking, while you are, working, doing the dishes, you should subscribe to the podcast edition. You can just listen at high speed and get through all of the content that we're producing. So go to university.com/podcast to sign up for the podcast edition. ASCII. How will dark energy overcome the pull of supermassive black holes in the hypothesis of the Big Rip? The Big Rip is this idea that dark energy, this force that is expanding and accelerating the expansion of the universe, isn't a fixed number. If you sort of imagine a cubic meter of space, and you imagine that for every new cubic meter of space, there is a little amount of dark energy that is now pushing outward. And so the more space you get, the more dark energy you get. That's the conventional idea of dark energy, which I know it's already mind-bending to think that this is happening. But we don't know the amount, the energy from dark energy is a constant or it actually is variable. Like maybe there were times in the early universe when it was a smaller amount, and maybe in the future it'll be a larger amount. And so one of the possibilities, if it is a larger amount, that you will get this expansion of the universe that is accelerating, and it will accelerate. And so the consequence of that is that, like right now, dark energy will never tear apart the Milky Way, because the gravity of all of the stars in the Milky Way, the gravity of the dark matter halo, holds the whole thing together. In fact, dark energy won't overcome our interaction with Andromeda. It won't overcome our interactions with any of the galaxies in the local group. But it's only when you get to dozens of light years away that dark energy is going to be the dominant force. And so these galaxies would normally be pulled together by their gravity, but at the same time, the dark energy is pushing them apart. And so they'll be like trying to fall towards each other, but they're actually falling away from each other. And so they'll just move away at accelerating rates. And that's just regular dark energy. So what if that is increasing? Well, then what that means is that after a while, Andromeda's falling towards us, we're falling towards Andromeda, and then the dark energy increases and they never quite get close enough, and then they start to fall apart. And then the dark energy overcomes the gravity inside the Milky Way and starts to pull the Milky Way apart. And then it pulls the solar system apart. And then it pulls planet Earth apart. And then it starts to pull black holes apart. And even eventually supermassive black holes, that there is nothing in the universe. If dark energy is accelerating, increasing, then there's nothing in the universe that could withstand this. And so it would be, if two things were welded together at the Planck scale, it would still pull them apart because nothing can overcome it. And so that's the Big Rip. And we still don't know if the Big Rip is a thing. We still don't know if the amount of dark energy changes over time. It would be surprising if it did. This is an idea that nobody can disprove yet, but there's no reason to believe that it's true. But there are a bunch of new spacecraft and observatories that are coming online. Vera Rubin, of course, on the ground is going to help with this. There's the Euclid mission from the European Space Agency, and then there's the Nancy Grace Roman telescope coming in 2027. So you're going to have these three instruments that one of their big jobs is to help collaborate to figure out and map out and get a really proper survey of where all of the dark matter, all the dark energy is, and how it's changed over time. And we will be able to either confirm that the universe is going to tear itself apart, or just put that idea to bed forever. Zachary Reed, what would you say to a young space enthusiast hoping to be a Mars colonist one day? What career path or skills would be in demand for such a venture? I would keep it more generic than that, because Mars sucks. Like, it's cold, it's airless, and there's no oceans, and there's no trees. And so like a lot of the stuff that we really love here on Earth, we don't have on Mars. But I think like just this general idea of being involved in the space exploration program is really exciting. And there's so many places, both here on Earth, as well as potentially in space. We may have a research station on the moon, research stations in orbit, research stations on asteroids, and a research station on Mars. And so like when you think about all of the billions of human beings and yet only a small handful, a few dozen, will be chosen to fly to Mars to be part of the exploration of Mars, you're going to need to have a very special set of skills, like probably a pilot, probably a scientist, probably an amazing other skill like doctor or mechanic or botanist or something like that. And so it's a lot of school, and it's going to be a fairly small group of people who actually get chosen for those kinds of missions. But like, you know, you've heard that classic quote, right? Like, if you aim for the moon and if you miss, you hit the stars. So like learning technology, learning skills, learning how to pilot a plane, learning different languages, like all of these kinds of education have so many practical applications in anything that you want to do. And so if you end up not being an astronaut, you'll have to settle for being an engineer at NASA who helps design spacecraft, right? Or you'll have to settle for being a test pilot who gets a chance to try out spacecraft, or you'll have to settle for being an engineer who works at a really cool startup that is building new kinds of wind turbines. So, I mean, I think that you can't go wrong investing in technology and science as a career, and you can do that today. I mean, there are so many places you can get involved in citizen science projects, like the American Variable Star Observatories group, or you can count birds and send in your data to the Cornell ornithology group. You can help count craters on asteroids. You can help identify galaxies. There's a lot of ways you can get involved today. And so I think, if you're planning to go into this, like, take science, go into just like general physics, or go into engineering at university, and then just keep following the kinds of science that you're really interested in. And then various job opportunities will open up for you. And one of them might be going to Mars. Oops kapoots. Plate tectonics is very important for life on Earth. How could we detect plate tectonics on an exoplanet? That is a really good question. And it's actually a really tricky question, because like Earth has plate tectonics, and as you said, it's probably extremely critical to life on our planet. While Venus, which is a planet that is the exact same size as Earth, almost, and is a little closer to the sun than Earth, and yet it doesn't have plate tectonics, and has a runaway greenhouse effect, and has a lot of other conditions that are different from planet Earth. And so if you were just looking at the mass of the planet, if you're looking at the radius of the planet, if you're looking at the transit, the size of the planet passing in front of the star, that wouldn't tell you that there is plate tectonics on that star. You would be looking at the kinds of gases in the atmosphere of the world. So when you look at Earth, as if you are looking at Earth with James Webb, as we talked about earlier in this episode, you would be seeing oxygen, you would be seeing carbon dioxide, you would be seeing methane, you would be seeing all of these other chemicals in the atmosphere. And yet when you look at the atmosphere of Venus, you don't see water vapor, or very much. You see carbon dioxide and you see other chemicals, but other stuff, it's a completely different signature. So that would be one way to go about it, is that you would be analyzing the atmosphere and you'd be looking for the kinds of chemicals. But still, it's really tricky. One of the problems in analyzing the atmosphere of another world is you don't necessarily get the quantities of that. So you can see the presence of certain chemicals in the atmosphere, but you don't know that it is like 70% nitrogen, 30% oxygen, or whatever it is on Earth. You see, oxygen, check, nitrogen, check, and you see a strong signal of nitrogen and a strong signal of oxygen. So we don't really have an easy way to be able to detect the existence of plate tectonics on another world. There have been some simulated hypotheses that a couple of the planets that have already been seen might have some kind of, based on the size of the planet, its distance to the star, the temperature gradients on the planet, that could be a world that has plate tectonics, but it's still a hypothesis. And so, I've been doing this reporting, and I can't think of an observation that you could make that would tell you that there's plate tectonics on a world. Now, one thing that might be part of it is being able to detect a magnetosphere. And so Earth is obviously surrounded by a magnetosphere. The magnetosphere interacts with the solar wind and produces auroras here on the surface of the planet, and also sends out radio wave emissions that go off into space. And so you can imagine, and we have detected the radio emissions coming from magnetospheres at exoplanets. Like, we knew the exoplanet was there because we detected the radio emissions coming from the auroras. And so Earth has a magnetosphere, but Venus doesn't. And Earth has plate tectonics and Venus doesn't. So maybe what's required is whatever is the range of conditions, like a molten rotating core also gets you a mantle with continents floating on top of it. But this is all very new, and I haven't heard like just, this is the way we do it. Now I want to find somebody to talk to. So put that into my brain for a future interview. Lulili. Could aliens look similar to Earth creatures? We always portray them as really strange looking in media, but considering we know what it takes for life to bloom, can they really look that different? Yeah, this is a fantastic question. And, we think about this idea of convergent evolution, that everything wants to be a crab. And so the crab body plan has evolved on Earth many times because it's a very useful, very efficient body plan. That if you've got multiple legs, you can move sideways, you've got claws in front, you've got a hard exoskeleton, all of these pieces come together to make a very efficient organism that has lasted a long time. And so if the process of evolution is happening on other worlds, you would expect them, we know that they're going to have the same physical characteristics to some degree. They're going to have mass, they're going to have gravity, they're going to have oceans of liquid water, they're going to have chemicals that are made of the various kinds of raw atoms that we have on Earth. Like, you would probably, if you went to some random exoplanet anywhere in the world and you started to dig up the stuff on the ground, you would find the same kinds of chemicals that we have on Earth. You'd find the same kinds of rocks, you'd find the same kinds of gases, you'd find the same kinds of liquids. There might be a few differences. There's a lot more minerals here on Earth than there are on Mars, for example, because of those plate tectonics, we had more chance for other chemicals to form. But like the raw stuff that life uses, it's all going to be the same. And so under the same conditions, we saw that life formed all these different kinds of crabs, or all these different kinds of trees. And so you would expect that on some exoplanet, because the same forces are involved, you're going to get similar body plans. Now, they're going to look different depending on the local gravity, the kinds of liquids that they're living in, and other, we don't know what's possible under evolution. We've only got a really tiny view of the history of the life forms on Earth, only the things that left fossils, dinosaurs and trilobites, but we don't see all of the soft body creatures that came before that. So I think the assumption is that we would see creatures, we would see life forms that would obey the laws of physics and chemistry and biology as we understand them, and yet they would have the variations that are possible under the laws of physics, under the laws of chemistry, and under whatever specific biology that they use. Life on Earth figured out DNA as a way to propagate and evolve, and maybe there's some other kind of chemistry that works on other planets, and then that could cause different kinds of proteins and different kinds of body plans based on that. But they would still have to interact with the world. They need to have a way to see, and binocular vision is a great way to see, or a compound eye is a great way to see if you have a smaller form, or having some kind of manipulator, opposing thumb. All these things make sense for evolution, and of course having a brain that can perceive its surroundings and sort of have a theory of mind of other beings. Those all seem like the kinds of things that would evolve many times. And so I think they would look alien, but once you saw an alien, you'd be like, oh, I get it. Right. Of course. They evolved under a heavier gravity, and they have access to these different kinds of things, and their body plans figured this out. But once you understand sort of the natural habitat that they evolved in, I think they would make sense. I think it's, things like Star Trek, of course, has everybody who are aliens just be human beings with a little bit of, something attached to their forehead. But that's because it's science fiction, and because you need actors, and the actors need to be able to see their eyes, and they need to be able to act. And so that is not a requirement for aliens. I really like, if you haven't already read Project Hail Mary by Andy Weir, there's a great alien in that, and they're making a movie, and I wonder how they're going to do that as a movie, or they're just going to change the alien in that. But yeah, I think when we see an alien, we won't be surprised. Like, we'll be surprised in the beginning, and then we'll be like, yeah, that makes sense. I get it. I see how they became the way they are. Derek Dibble, will the successor to Hubble really only be the same size as JWST? Starship and SLS Block 2 will both be flying by then, which could hold a much bigger mirror. Yes, the plan for the Habitable Worlds Observatory, which is going to be the successor to the Hubble Space Telescope, and which is sort of like a scaled down version of LUVOIR, which we've been excitedly talking about for years, will have a 6.5 meter mirror. So it'll be the same size as JWST, but it won't need the same kind of cooling system. So it will be a simpler telescope from that perspective, but it's going to have a much more sensitive set of instruments, and the main mirror, because it's in the visible spectrum, will have to be a lot sort of finer polishing, much more optically perfect. And I did an interview with Lee Feinberg, and we talked about sort of what are going to be the requirements of that. He's the optics designer behind JWST and Hubble, I think. And so he was talking about sort of what it's going to take. And yeah, a lot of emphasis is going to be on the optics of this system, on the primary mirror and the instruments that are attached to it, and less on the heat management like we had with JWST. But then the other thing it's going to have going forward is it's going to have this Starship, which is a second spacecraft that's flying tens of thousands of kilometers away, and is maneuvering to get in front of stars so that it can block the star and allow the telescope to be able to perceive the planets that are orbiting around it. And so in theory, it's going to be able to see about 24 Earth-sized worlds orbiting around sun-like stars. In fact, there was another story that we reported on this week. There's some cool ideas on how to extend that even more, that maybe you could end up with about 50. And remember, we don't know of any right now, right? We know of 0 of these potential candidates. And yet the assumption is by the time this telescope was built, there will be enough that we know of that it will be able to look at 25 to 50 of these planets and study their atmospheres. Could you make a bigger telescope? Of course, you can make a bigger telescope, but this is what happened with Webb. Was they said, could we make a bigger telescope? Yes. Okay. But now we're going to have to make something which is lightweight, and it's going to have to fit within standard rocket fairing and all this kind of stuff. And the budget's ballooned, and the time frame slipped, and it gobbled up the budgets of a lot of other projects. There's a lot of really cool telescopes that you'll never hear about because their budgets were canceled because they had to keep spending on Webb. And so they're not going to make this mistake again. They've learned their lesson. They're going to remain within a certain amount of risk with each iteration, and they're going to make sure that they try to get it on time, on budget, and have it fly. And so I don't think you're going to see the same kind of cost overrun, time overrun with the next generation telescope. I think that's job 1 is don't mess this up. Job 2 is build a telescope and everything from that. Now, it could very well be that we get 20 years down the road and Starship V5 is flying and it only costs $1 million to launch, and it's perfectly safe and completely reusable and offers a 9-meter fairing, or maybe the 18-meter fairing is available. And that offers incredible design improvements. I mean, it knocks the price off of the launch by $1 billion, and also makes it so you don't have to make the telescope so small and so lightweight. But when you think about Webb, the challenge was not the size of the telescope, although that was one of them. The challenge was the weight. That the hardest problem that they had was shaving down the weight from every single component of that telescope, and yet it's still being able to do its function so that it could fit within the weight capacity of one of the heaviest launch vehicles that was available at the time. And so if you've got something that could launch dramatically more weight, has a much larger fairing, then the design process gets simpler. The whole thing comes down in budget. Maybe the time frame moves up because they're whatever, we'll just, we'll make the struts out of stainless steel. We don't care. But I don't think we're going to see anyone offer up like, we've got a new rocket, so let's build a bigger telescope, right? And everyone would be like, look at step 1, don't mess this up. Right, okay. 6.5 meter telescope, star shield, let's do that. And so I think that is going to be the primary objective here, is to build the instrument that sees these worlds and nothing more. And that's what we're going to get. Now, I'm going to talk about a video game that I'm playing right now that I think you should too. But first, I'd like to thank our patrons, Mark Anstius, Joel Yancey, Antonio Lofilara, Dustin Cable, Just Paul Davis, Vlad Shiplin, Jay Dennis, David Giltinan, Maud So, George, Jeremy Mattern, Jordan Young, Tim Whalen, Dave Verbeoff, Andrew M. Gross, and Josh Schultz, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So people have been asking me if I've been playing Starfield, and the answer is no, I haven't. I haven't even like looked at a trailer. I haven't watched any gameplay footage, and I'm just gonna wait until there's like a really killer sale, and then maybe I'll pick it up down the road. But like I played Skyrim, and I didn't really like it that much. After a while, it felt very repetitive, and I suspect that that's, you know, I played my share of Betazed games, the Fallout games. I like Fallout New Vegas. The rest, meh. But apparently people are now, because of Starfield, people are playing No Man's Sky, and I'm one of them. I've had No Man's Sky right from the beginning, and I played it off and on. But I've heard like all of the new content they've added to the game, and I picked it up like a week ago or so, and I really am enjoying myself. It's a very chill experience that you just sort of wander this galaxy following whatever whim strikes your fancy at the time. You see a planet, you go down to that planet, you talk to an alien, the alien sends you on a thing, you jump to another system, there's a battle going on, you take part in the battle, and it's kind of amazing how much content they've added to this game in the last 7 years of just constant improvement. It is so polished at this point. You can run a colony, you can run a freighter fleet with frigates, you can fly in the frigates, you can take part in these giant space battles, you can build your own bases, you can have underwater bases, you have exosuits, you have submarines you can build. Like, it just goes on and on and on, and they're just constantly making improvements. They have activities every week. And like, they're not sponsoring me. I'm just like, I just can't believe how much fun I'm having in this game. That like, when I first saw the ad for No Man's Sky, I was like, that's the coolest game ever. And then when it actually delivered, it was not good. It was very boring. It was a very repetitive experience. But kudos to the team. They just had their heads down year after year after year, delivering so many updates. And I really like it. Now, I don't know if it'll have the same kind of lasting fun for me that something like, say, RimWorld or Project Zomboid did. But for now, I'm playing it pretty obsessively, and I'm playing it only on the Steam Deck, which works really well. Now that I've got glasses, I've got a pair of reading glasses just for playing video games and on the Steam Deck, and that's made a big difference. So yeah, I'm an old man. All right, we'll see you next week.